This is problem number 9 from section 4.2. In this problem it says complete parts A through C for f of x, which is this piecewise function. It wants us to sketch a graph of f, determine if f is continuous on its domain, and then solve for the zeros for this function. Let's start by drawing a coordinate plane. So this is part A. We're going to draw a pretty nice sized graph here. And we're going -3 to 3 is the domain. So the x values, I'm going to go 1, 2, 3, 1, 2, 3. And let's mark up 1, 2, 3, 4, 5, down 1, 2, 3, 4, and 5. All right, now I need to plug in -3 all the way up to 0 for this function. And I'm actually going to plug in some that are in between there to make sure that, I see it's a quadratic, so I see there's a little bend. So I'm going to do f of -3, f of -2, f of -1. I'm going to do f of 0 for this first one. So I'm going to plug all those in. I'm going to do most of that with the calculator. So let's go ahead and type in the function. I'm going to use, well, we're going to store this first number, -3, store it as x. And then we're going to say x squared minus 4 and hit enter. It tells us that this is 5. So I'm going to kind of cover up my function for right now. This is 5. And then I'm going to do the same thing here. I'm going to plug in the -2. So I'm going to say -2, store it as x. And then plug this in. Grab that function. That's 0. And then I'm going to plug in -1, store it as x, grab the function again, it's -3, and finally I'm going to grab 0, so 0, store it as x, grab that one last time, and I get -4. So let's graph it now. Graph in a different color. This first part, we're going to label it brown. So x squared minus 4, when I plug in -3, I get 5. -3, 5 is up here, and that is part of the domain. So I'm going to close dot on that one. -2, 0. So that would be -2, 0 would be here. -1, -3. -1, -3 is here. And finally, I got 0 and -4, but 0 is not part of the domain, so I'm going to put an open circle right there. And this is the graph of the first function. Now the second function, we'll do that in red. I'm going to plug in 0 to 3. So I'm going to do f of 0, f of 1, f of 2, f of 3. Plug all those in. So I'm going to start by storing 0 as x, and then type in 4 minus x squared. That gives you 4. Now 1 stored as x, grab that function. I get 3. Now do 2, so 2, store it as x, and let's go grab that, 0, and then finally 3, store it as x, -5. So let's plug those in on the graph. F of 0 is 4. So 0 for x, 4, That's up here. That's a closed dot because of the less than or equal to signs. So closed dot here. F of 1 is 3, so 1 and 3. 2 and 0. And then 3 and -5. So this is the function there. All right, now we've sketched the graph. That's part A. That took quite a bit of time, but graphing by hand does. Part B, determine if f is continuous on its domain. So for part B, I'm just going to write this here. No, it's not continuous because it jumps at x equals 0. That's part B. Now part C. It says solve f of x equals 0. We can actually just solve this by looking at the graph. You can see in this graph that we have two zeros. We have x is -2 and x is 2. So our zeros are x equal -2 and x equal 2. So that's solving f of x equals 0. If you have the graph, you can just look right at it. Hope that makes sense.